Hey guys, so today we're just going to be kind of talking about day two, doing a few more examples with some imaginary numbers. So that's exciting. Actually, a lot of today's examples are very similar to what they were the other day. You're going to be trying the next few problems in the set. I will tell you what numbers they are in Google Classroom. And you're just kind of continuing to work in that problem set. And just as a reminder, you're just trying. So I know it's kind of hard with me not being there. But life problems during COVID at this point. So we'll just do our best and then I will make sure I go over everything when we get back. So I'll kind of get a feel of how you guys are understanding stuff. And if there's something you get, then that's great. And if there's something you don't get, we will obviously go over it way more. So today we'll just do a little bit more multiplying, a little bit more simplifying. And then hopefully I'll be back to you soon. So let's just do a few multiplying problems. And some of these may look similar to what we were doing the other day, but that's okay. Never hurts to do more examples. So with this multiplying, let me just do the first example. Square root of negative 2 times the square root of negative 6. So the main goal, we kind of go back and forth. Sometimes you'll see i's in the problem. Sometimes you'll see negative square roots. We just want to make sure we know what that represents. So before you multiply, so please do not multiply and say, oh, a negative times a negative is a positive. No, don't do that. You always want to take care of the negatives under the radicals first. So we're going to turn those into i's. So we would write this as I square root of 2, because I can't do anything to the square root of 2. Can't simplify that. And same thing here. I can't simplify the square root of 6, but the I will take care of the negatives. We write it as I square root of 6. So now that we have that, now we can multiply them. I times I, we talked about that, is I squared. Underneath my radicals, 2 times 6 is 12. And we want to simplify as much as possible. 12 we can break down. 4 times 3, so that would be 2 root 3. And then just as a reminder, this I squared, we need to say what the heck is that? And that turns into a negative 1. So I can just basically throw that negative there. If you want to do negative 1 times 2, go for it. But that would be my final answer to that problem. So in general, when you're giving an answer to a problem, you should never have a negative under a radical. You should never leave things as I squared. So those are just little things that you want to be on the lookout for, just to make sure we are properly giving our answers. So let's look at another one. Once again, these ones today won't be too bad, and they're very similar to the ones you guys were trying the other day, whenever the heck that was at this point in life, but we'll just do our best. So like this one looks pretty basic, but just make sure you can kind of follow along. We do want to multiply them. I times I squared will just give us I to the third. Okay, that makes sense. And the other day, I kind of listed them out for you from I to I to the fourth, what they represented. So I, you just kind of keep as I. I squared is negative 1. When you see I to the third, we're going to write that as negative I. Oops, it helps if you put the negative aside, Mrs. Sherman. Negative I. And then if you had I to the fourth, it would just be 1. So those are going to pop up quite a bit as we're going in the future. But in your answer, if you ever see an I to the third, you rewrite it as negative I. So it's an equivalent, but just simplified. And then let's say you had something like the square root. Oh my God, I can't even write the square root. P.S. I'm doing this on a Sunday morning. I'm like bribed my daughter to go watch Paw Patrol. Hopefully she stays there. So I'm a little rusty here on a Sunday morning. But if I had something like the square root of negative 9 squared. So let's just think of it logically. When I square something, or excuse me, before I square something, always take care of this, right? So always take care of that negative and turn it into an I. And I know the square root of 9 is 3. So I can rewrite this as 3i squared. Okay. When I think of 3i squared, just think about 3i times 3i. That would give me 9i squared. And then anytime you see I squared, that's going to turn into a negative 1. And that would just come out to be negative 9. And then just as a heads up, it's something you've probably done a million times, but when you take this, when you square a square root, you're basically left with what's underneath the radical. Same thing happens here. Basically, the square and the square root cancel each other, and you would just be left with negative 9, but then we kind of showed our work to show us that. But if that's something that you recognize in the future, beautiful. So that's that. So just a little reminder about multiplying. Things like negatives under square roots, you turn into I before you multiply, and then you just kind of go through the motions and just doing as much simplifying as you can as you're doing those. So that's that. So let's look at a few just simplifying problems. So maybe there's some other fun stuff mixed in with these bad boys. So something like this. 12. Sorry, just drop my pen. 12 plus 6i minus 2 minus 5i. So simplify means you can add, subtract, you can multiply. We haven't done division yet. We'll do that later. But like, what do you have to do to combine? In this case, I just see addition and subtraction. So my goal is to really, just as a reminder, is to combine like terms. So think about i's as you would as any variable. You just you can combine an I with an I. So in this case, I can combine the 12 with a negative 2, because those are just regular old constants. That would give me 10. And I can combine the 6i with the minus 5i, and that would just give me 1i. Or you could just write I, you don't have to write the 1. And that's how your final answer would look. Just as a reminder, you cannot combine an I with a real number. So we say this is the imaginary part and this is the real part. And that's what makes up a complex number. So a complex number does have two parts. So just as a heads up. Well, I'm going to label that as number 4, just so I can keep track of my life as I'm going here. So let's try 5. So something like this. And I think once again, we did a few of these the other day, but it's always good to see a few more. Especially, I'm sorry that you're watching these on video, but you do know it's kind of a mess at the Sherman house right now. So we'll just do our best. So if I said simplify that, you would say, oh, I'm just multiplying two binomials. To do that, I'm going to distribute. So let's do some distributing. Negative 2 times 4 is negative 8. Negative 2 times 3i is negative 6i. Okay, so I'm just multiplying like normal. 7i times 4 is plus 28i. And then, that was an awkward thing, 7i times 3i is 21i squared. So just be careful with that I times I, that is an I squared. You can kind of do this however you please, but the one thing you do need to do is when you see an I squared, you do need to replace it with a negative 1. So I usually kind of just do this, and I make it a minus 21. So instead of plus 21i squared, since the I squared turns into a negative 1, I just write it as minus 21, or you can rewrite it if you please. But something to just organize your brain to remind you of that. You shouldn't have I squared in your answer. They should always be replaced with negative 1. Now we can combine like terms. We have negative 8 and negative 21. That's going to give me negative 29. We have negative 6i and 28i, and that will give me 22i. And then once again, that's how a complex number is set up. So that would be your final answer. You have your real and your imaginary parts, and they kind of have to stay separate. So we know we've distributed a million times this year, I feel like. But just as a reminder, with those i's, just kind of keep track of them and make sure whenever you see I squared, you do replace it with a negative 1. Okay, I only have 2 more problems. So once again, today, a lot of this is stuff we saw the other day, but just trying a few more and kind of seeing how we feel. So let's say we had this 4 plus the square root of negative 3, and then 2 plus the square root, I want to make that a minus, minus the square root of negative 6. Sorry, don't have an eraser today. It actually looks very similar to the other one. It's just a distributing problem, right? But before you distribute, I'm sorry, why did I awkwardly put 2 square root symbol? Oh my gosh. Okay, I'm just going to rewrite this because Sherman's a struggle bus this morning. So 4 plus the square root of negative 3 times 2 minus the square root of negative 6. Okay, that's looking better. I don't know what I was doing there. So it's actually almost the same exact thing that we did with number 5. Why is this not moving? Okay, there we go. It's just instead of being written in terms of I, it's written in terms of a negative radical. I always rewrite it in terms of I, so that should be your first step. So I'm going to rewrite this as 4 plus I root 3. Once again, we don't want the negatives underneath. We do have to change it. And then 2 minus I root 6. Okay, so rewrite that as your first step. Now you can distribute. So the distributing's review for us, we would get 8. And then we would write that as minus 4i root 6. And as we distribute here, that would be plus 2i root 3. And then last but not least, we would have minus I squared root 18. All right, we got some stuff going on here. So what I notice is at this point, like I can't combine these two things, right? These are different radical. Oh, excuse me. Yeah, they're different radicals. They both have i's. So you have to kind of keep them separate. The one thing I can do is kind of look at this last thing and simplify that. Because what I notice is the I squared is going to turn into a negative 1. And I can break down this radical. That would simplify to 3 root 2. So I'm going to take this and I'm just going to rewrite it. Since it was minus and negative, it's going to turn into a plus. And then we said root 18 was 3 root 2. And as I'm looking at my answer, I'm like, there's like nothing else I could do. I kind of tend to like to kind of group things. So I'm going to put 8 and I'm going to put the 3 root 2 together just because they're both real parts. It's just I can't technically combine them because the radical would have to be the same. And then I'll put the imaginary parts together. But then once again, I can't do anything to actually combine them. And that's perfectly fine. I feel like sometimes we just want to keep combining until forever. But sometimes you just can't do anything else, and that's just life. So that's how we would leave that answer. If you had to kind of change the order of these, that's fine. I just like to put the real parts together, the parts that don't have eyes, and then the imaginary parts together. So just as a heads up for that one, and then just one more. So the last one kind of brings in what we've been doing. Hold on one second. Yes. Well, you're going to have to wait a minute. Sorry, my daughter needs pretzels. It's obviously a pretzel emergency right now, so she's going to have to wait for one more problem, homegirl. So you got 2 plus 3i squared. And then just as a reminder, whenever you're squaring anything, please do not just square both of these and say you're done. When you square something, that means you take that binomial and you multiply it by itself. And then it just brings it back to all of the fun distributing we've been doing. So let's distribute this bad boy. That will give me 4. When I distribute it, that will give me plus 6i. And then my second term would be plus 6i, and then plus 9i squared. So do what you have to do. If you need to rewrite it, go for it. I kind of just at this point say, okay, I have this. This turns to a -1. So that would just be -9 now, right? Just to kind of save myself some steps from having to rewrite it. Now let's combine like terms. In this case, I can, no problem. 4 minus 9 gives me -5. And then 6i plus 6i gives me plus 12i. And then once again, that would be my final answer because there's nothing else I can really combine. So hopefully those are looking semi-familiar if you watched the other day's video. We're just going to do our best over the next few days and kind of see what comes of it. And just as a reminder, if you're like, I'm so confused right now, just do your best. And I will be re-going over all of this with you in class. So please bear with me. I know it's a little bit tricky to navigate these times, but we're just going to do what we can at this point. So check Google Classroom for your assignment, kind of based off these. You can always email me with questions, and we'll go from there. Have a good day, guys.